Look up at the night sky. What do you see? A breathtaking, seemingly endless expanse of stars, galaxies, and faint cosmic glows. It feels infinite, doesn't it? A cosmic ocean without a shore. But what if I told you that everything you've ever seen, every star, every galaxy captured by our most powerful telescopes, exists within a giant, invisible bubble? And beyond the edge of that bubble, there's a universe we can never, ever see. This isn't science fiction. This is the reality of our cosmos. This bubble is called the observable universe. It's not a physical wall, but a horizon in time. The universe began about 13.8 billion years ago with the Big Bang. Since then, light from the most distant objects has been traveling through space to reach us. The furthest light we can possibly detect has been on its journey for nearly the entire age of the universe. This creates a boundary, a sphere around us, with a diameter of about 93 billion light-years. Why so large? Because the universe itself has been expanding the entire time that light has been traveling. Everything we know, every piece of data, every breathtaking image from the James Webb Space Telescope is from inside this cosmic sphere. Within it are at least 2 trillion galaxies, each with hundreds of billions of stars. It's a staggering amount of stuff, but it's still just a finite patch of a potentially infinite reality. So, the billion-dollar question is, what lies beyond that horizon? What's outside our bubble? The honest answer? We don't know for sure, but the most logical assumption is simply more universe. More galaxies, more stars, more planets, stretching on and on, because space itself is expanding faster than the speed of light in the far reaches of the cosmos. Light from galaxies beyond our observable horizon will never have enough time to reach us. They are receding from us too quickly. It's like trying to catch up to a car that's accelerating away from you faster than you can run. You'll never get there. This concept is both humbling and mind-bending. It means our view of reality is fundamentally limited. We are, in a sense, on a cosmic island, unable to see the full extent of the ocean we're in. We can theorize about what's out there. Maybe the universe goes on forever, looking much the same as it does here. Or perhaps, in the vast, unseen cosmos, the fundamental laws of physics are different. Maybe there are other bubbles, other universes, in a grand multiverse. We might never have a definitive answer, but pondering the question itself expands our own minds. Our observable universe is a precious, limited window into an unimaginable whole. What we can see is incredible, but what we can't see is the ultimate mystery. Have you ever looked up at the night sky and wondered where it all ends? Is there an edge to the universe? The answer is both yes and no, and it will stretch your mind in the most fantastic way. To find this edge, we can't just point a telescope and look. We have to travel back in time, all the way to the very beginning. Picture this, 13.8 billion years ago. There's no space, no time, no anything as we know it. Then, in an instant, everything bursts into existence from a point of unimaginable density and heat. This wasn't an explosion asterisk in asterisk space, like a firework. It was the explosion asterisk of asterisk space itself. Every single point began rushing away from every other point. Think of it like the surface of an expanding balloon. If you draw 2 dots on it and inflate it, the dots move apart, not because they are crawling across the surface, but because the surface itself is stretching. That's our universe. In the first chaotic moments, as the universe expanded, it also cooled down. The fundamental forces of nature gravity, electromagnetism split apart. Protons and neutrons, the building blocks of atoms, started to form. A few minutes later, these combined into the first atomic nuclei, mostly hydrogen and helium. But for a long, long time, the universe was a super hot, dense fog. It was a cosmic soup of charged particles, protons, nuclei, and free-roaming electrons. In this foggy state, light was trapped. Photon, a particle of light, could untravel more than a tiny distance before slamming into an electron and scattering in a random direction. The entire universe was opaque, like being inside the thickest cloud you can imagine. You couldn't see anything. This period lasted for about 380,000 years. It might sound like a long time, but on a cosmic scale, it's just a blink. Then, a pivotal moment happened. The universe had cooled enough for electrons to finally be captured by the atomic nuclei, forming the first stable neutral atoms. Suddenly, the fog cleared. With the free electrons now bound up in atoms, the photons were set free. For the very first time, light could travel unimpeded across the cosmos. This moment is what astronomers call the surface of last scattering. It's the moment the universe became transparent. That ancient light, released 13.8 billion years ago, is still traveling through space today. It's all around us. Can't see it with our naked eyes because, over billions of years, the expansion of the universe has stretched its wavelength. What started as brilliant visible light has been stretched into the microwave part of the spectrum. Call this the cosmic microwave background, or the CMB. When we point our radio telescopes at the sky, we can see this faint uniform glow coming from every direction. It's the oldest light in the universe, the very first picture of the cosmos we could possibly take. And this, my friends, is the edge of our observable universe. We cannot see past the CMB with any traditional telescope, because we are looking back to a time when the universe itself was an opaque wall of fog. It's not a physical wall in space, but a wall in asterisk time asterisk. Looking beyond it means looking into a time before light could travel freely. Now, here's where your brain might start to melt a little. The universe is 13.8 billion years old. You might think the edge of the observable universe should be 13.8 billion light years away, right? It's the distance light could travel in that time, but it's not. The actual distance to that edge is a staggering 46.5 billion light years. How is that possible? How can we see something that's farther away than the age of the universe in light years? The secret is that pesky, wonderful expansion of space we talked about earlier. Remember the balloon? The photons from the CMB started their journey towards us 13.8 billion years ago. But while they were traveling, the space they were traveling asterisk through asterisk was also stretching. The region of space that emitted that light was much closer to us when the light began its journey. But over the eons, that region has been carried much, much farther away by cosmic expansion. Imagine a tiny ant walking on a stretching rubber band. The ant is the photon walking at a constant speed. The rubber band is space, constantly expanding. By the time the ant reaches the end, the starting point is now much farther away than the distance the ant itself walked. That's what's happened to the light from the edge of our observable universe. This creates a boundary known as our cosmic horizon. It's the absolute limit of what we can see. Any light from beyond this horizon simply hasn't had enough time to reach us yet, because the universe isn't old enough. It's like being on a ship in the middle of the ocean. You can see to the horizon in every direction, and it forms a perfect circle around you. Our observable universe is like that, but in 3 dimensions, it's a perfect sphere with Earth at the very center. But here's the most humbling part. There is nothing special about our location. We are not at the center of the actual asterisk universe. An alien astronomer on a galaxy billions of light years away would see their own observable universe, a sphere centered on their planet. Their sphere would overlap with ours, but they would see parts of the cosmos that are forever hidden from us, beyond our horizon. And we see parts of the universe that are beyond theirs. This means the observable universe is not the entire universe. It's just our little pocket, our cosmic bubble of perception. The true universe is almost certainly vastly larger than what we can see, and many physicists believe it might even be infinite. There could be countless galaxies, stars, and maybe even other forms of life beyond our cosmic horizon that we can never, ever see or interact with. So the edge of the universe isn't a brick wall or a cosmic dead end. It's a boundary of knowledge, a horizon defined by the finite speed of light and the finite age of the cosmos. It's a beautiful, profound reminder that as much as we know, there is always more to discover, more to wonder about. We stand on the shore of a cosmic ocean, peering out at a horizon we can never reach, knowing that an unimaginably vast reality lies just beyond our sight. What lies at the edge of everything? When we gaze into the deepest night sky, we're not just looking into space, but back in time. And at the farthest reaches of our vision, the universe presents us with a series of cosmic landmarks, not physical walls, but milestones that define the very limits of what we can know. Today we journey to the horizon of existence to explore these incredible features. First, let's talk about the observable edge itself. Imagine we're at the center of a colossal bubble. This bubble isn't made of anything physical. It's a bubble of light. Its radius stretches about 46 billion light-years in every direction. Why this specific distance? Because light from anything beyond that boundary simply hasn't had enough time to reach us since the universe began 13.8 billion years ago. You might wonder, wait, why 46 billion light-years if the universe is only 13.8 billion years old? That's because the universe has been expanding the entire time that light has been traveling. The space that light had to cross has stretched, making the journey much longer. It's crucial to understand this isn't the edge of the entire asterisk universe. The cosmos itself might be infinite, or it might curve back on itself in ways we can't yet measure. The observable edge is simply our personal horizon, the boundary of what we can see from our specific vantage point in space-time. Everything we've ever detected from our neighboring Andromeda galaxy to the most distant quasars exists within this sphere. This bubble is our cosmic stage, and for now, everything outside remains a profound mystery. Now, let's travel further back in time to encounter the next landmark, the Cosmic Microwave Background, or CMB. This is, without a doubt, the oldest light in the universe. Discovered by accident in 1965, the CMB is a faint, uniform glow of microwave radiation that fills the entire sky, no matter where we look. It's the afterglow of the Big Bang itself. This light was released when the universe was just a baby, about 380,000 years old. Before this moment, the universe was an incredibly hot, dense, and opaque plasma. Think of it like a thick, glowing fog where light particles, called photons, were constantly scattering off charged particles, unable to travel freely. But as the universe expanded, it cooled down. Eventually, it became cool enough for protons and electrons to combine and form the first neutral atoms. Suddenly, the fog lifted. Photons were set free, streaming unimpeded across the cosmos. The light we see today, as the CMB, is made of those very photons, which have been traveling for over 13 billion years to reach us. They carry a snapshot of what the universe looked like at the moment of its first light. What's truly remarkable about the CMB is that it's not perfectly smooth. If you look closely with sensitive instruments, you'll find tiny, almost imperceptible temperature fluctuations, differences of just 1 part in 100,000. These tiny ripples might not seem like much, but they are the seeds of everything we see today. The slightly hotter, denser spots were areas with a little more matter, a little more gravitational pull. Over billions of years, gravity amplified these tiny variations, pulling in more and more material. These were the primordial seeds that grew into the vast cosmic web, the galaxies, the clusters of galaxies, and the great voids in between. So, when we look at the CMB, we're not just seeing the oldest light, we're looking at the blueprint for the entire universe. We're seeing the embryo of our own Milky Way galaxy. This brings us to our third landmark, which is intrinsically linked to the CMB, the surface of last scattering. When we observe the cosmic microwave background, we are effectively looking at a spherical wall all around us. But it's not a physical wall, it's a wall of light. It's the point in time and space where the photons of the CMB last bounced off matter before traveling directly to our telescopes. Remember that hot, dense fog of the early universe? The surface of last scattering is the edge of that fog. Before this surface, the universe was opaque, so we can't see past it with conventional light-based telescopes. It's like being in a dense fog on Earth. You can only see as far as the point where the light is no longer scattered. For us, that point is 13.8 billion years in the past, forming a sphere around us. Every CMB photon we detect began its final, uninterrupted journey from the surface. It is the ultimate barrier for our eyes and telescopes. The farthest back in time we can look using light. But is light the only messenger from the early universe? Not at all. And this is where our quest to see even further back in time gets truly exciting. While the CMB marks the limit for light, other, more elusive particles could allow us to peek behind that curtain. First, there's the cosmic neutrino background. Neutrinos are incredibly tiny, almost massless particles that barely interact with anything. They decoupled from the primordial plasma just 1 second after the Big Bang, long before photons did. This means they carry information from an even earlier, more extreme epoch. Detecting these ancient neutrinos would be like hearing the universe's first heartbeat, but they are so ghostly and weak that they remain beyond our current technological grasp. Then there are primordial gravitational waves, ripples in the fabric of space-time itself. These waves are thought to have been generated during cosmic inflation, a period of hyperexpansion that happened a mere fraction of a second after the Big Bang. If we could detect these gravitational waves, they would provide a direct window into the very first moments of creation, pushing our cosmic horizon back almost to the beginning of time itself. These are the next frontiers of cosmology. While we work on detecting those ancient signals, powerful instruments like the James Webb Space Telescope are already giving us breathtaking views of another key landmark, the first galaxies. These are some of the earliest complex structures to form in the universe. Lighting up the cosmos just a few 100 million years after the Big Bang, they exist incredibly close to the edge of our observable bubble. Studying these faint, distant galaxies is like being an archaeologist of the cosmos. We're watching how the first stars ignited, ending the cosmic dark ages. We're seeing how matter, guided by the blueprint in the CMB, began clumping together to form the first recognizable cosmic structures. Each new galaxy discovered at this extreme distance is like finding a lost chapter from the universe's origin story, helping us piece together the grand narrative of how a uniform sea of primordial gas transformed into the rich, structured cosmos we inhabit today. So when we put it all together, we see that the edge of the universe isn't a single line. It's a rich, layered map defined by these incredible landmarks. We have the observable edge, our bubble of light. We have the CMB and its surface of last scattering, the oldest light we can see, which also serves as the blueprint for cosmic structure. We have the earliest galaxies, the first bright beacons to emerge from the darkness. And looking to the future, we have the tantalizing promise of neutrinos and gravitational waves that could let us peer even further back. These aren't just abstract concepts. They're the guideposts that anchor our entire understanding of the Big Bang, the expansion of the universe, and our place within it. Every new observation pushes these boundaries, refining our map and deepening our appreciation for the vast, beautiful, and still largely unknown cosmos we are so lucky to be a part of. Have you ever looked up at the night sky and wondered, does it ever end? What lies beyond the furthest star we can see? Today we're going on a journey to the very edge of reality, to the frontier of cosmology, where science meets profound speculation. We're asking, what lies beyond the observable universe? When we talk about the edge of the universe, we're not talking about a physical wall. We're talking about a horizon of light. Since the universe is about 13.8 billion years old, we can only see objects whose light has had 13.8 billion years to reach us. But the universe has been expanding that whole time, so that edge is now about 46.5 billion light-years away. Beyond that, a veil. A boundary not of space, but of information. This leads to one of the biggest questions in all of science. Is the universe finite or infinite? Our best measurements suggest that, on the largest scales, space is geometrically flat. If you could travel in a perfectly straight line, you'd never curve back around to where you started. And a flat geometry often implies an infinite universe and endless cosmic oceans stretching on forever. But the idea of infinity makes many physicists a little uneasy. It's a mathematical concept, but does it exist in physical reality? It could be that our universe is just unimaginably vast, far larger than what we can observe, but still finite. Think of the surface of the Earth. It's finite, but it has no edge you can fall off. Our universe could be a higher dimensional version of that, a closed but boundless shape. The frustrating truth is we may never know for sure. Anything beyond our cosmic horizon is, by definition, hidden from our view. And here, a mind-bending twist. Even parts of the universe we can see now are becoming unreachable. This is because the expansion of space is accelerating, driven by a mysterious force called dark energy. Galaxies beyond a certain distance are now moving away from us faster than the speed of light. Now, nothing can travel asterisk through asterisk space faster than light, but space itself can expand at any speed. This means that the light leaving those distant galaxies today will never, ever reach Earth. It's like trying to swim upstream against a current that's faster than you can swim. This creates a cosmic event horizon, a point of no return. We are effectively watching most of the universe slip away from us. In the far, far distant future, observers on Earth will only be able to see our own local group of galaxies. The rest of the cosmos will have faded into an unreachable darkness, forever hidden from view. So, what could be out there in that vast, hidden expanse? This is where we enter the realm of the multiverse. The most popular theory for the universe's origin, cosmic inflation, suggests that our universe was born from a rapid, exponential expansion of space just a fraction of a second after the Big Bang. Some models of inflation predict that it wasn't a one-time event. Instead, it might be happening eternally, constantly spawning new bubble universes like ours. If this is true, our universe is just one bubble in an infinite cosmic foam. And each of these other universes could be radically different. They might have different laws of physics, different fundamental constants, or even different dimensions. Imagine a universe where gravity is weaker and stars could never form, or a universe made of matter completely alien to us. The multiverse hypothesis is one of the most provocative ideas in science. Of course, since these other universes are by definition unobservable, some argue it isn't science at all. But it emerges naturally from our best theories about the cosmos, making it a possibility we have to take seriously. But even if our universe is the only one, what lies beyond our horizon? It might not be some exotic new physics, but simply more of the same cosmic web of galaxies and voids that we see within our observable sphere. But the structures out there could be on a scale we can't even comprehend. We see superclusters of galaxies and vast cosmic voids, but are these part of an even larger, repeating pattern? Imagine you're an ant on a single thread of a giant Persian rug. From your perspective, you see a long line. You have no idea that you're part of a complex, beautiful, and ordered design that stretches far beyond your sight. Could be in the same position. The part of the universe we see might not be representative of the whole. We are stuck in our tiny observational patch, unable to see the grand cosmic tapestry in its entirety. This also raises the question of whether the laws of physics themselves are constant everywhere. Could the fundamental constants of nature, like the speed of light or the strength of gravity, be different in other distant regions of our own universe? Some theories allow for this. Maybe the dark matter and dark energy that mystify us so much behave differently in other cosmic domains, leading to universes with completely different fates. Or perhaps space itself is twisted in some complex way, a topology that could, in theory, allow you to look in one direction and see. It's the back of your own head, though we've found no evidence for that so far. All of these incredible possibilities lead us to a very humbling conclusion. There may be fundamental truths about our universe that are forever beyond our grasp. The cosmic horizon isn't a technological barrier we can one day overcome with a better telescope. It's a fundamental limit set by the laws of physics themselves. We may never know if the universe is infinite, or what lies beyond our sight. But that's what makes this quest so beautiful, so powerful. The edge of the observable universe is also the edge of human knowledge. To explore what lies beyond, we can't use telescopes. We must use our most powerful tools: mathematics, theory, and the limitless power of our imagination. We stand here in our small illuminated bubble, gazing out at an endless ocean of darkness, and we wonder. And that wonder is what drives us forward. For almost all of human history, the sky was a ceiling. Beautiful, star-studded dome, but a dome nonetheless. It was fixed, finite, and eternal. The horizon, whether you were standing on a mountain or sailing across the ocean, was the absolute edge of the world. It defined the limits of what we could see, and therefore, what we could know. Today, thanks to science, that horizon has been pushed back. We now know that the universe extends at least 46 billion light-years in every direction from us. It's a sphere of observable reality so vast it's almost impossible to comprehend. And yet, here's the cosmic irony. We are still trapped inside a horizon. It's not a geographical one anymore, but a cosmic one. The boundary of the observable universe. This isn't just some abstract fact for astronomers to ponder. This cosmic horizon directly shapes how we understand our place in the cosmos, how we build our models of reality, and even how we think about what it means to be human. It's a concept that is both deeply scientific and profoundly personal. Think about any map you've ever seen. It's from a crinkled medieval parchment showing monsters at the edge of the world, to the GPS on your phone. Every map has a boundary. For cosmology, the science of the universe itself, that boundary is the observable universe. When astronomers create models to understand how the cosmos works, they are fundamentally limited by the data they can collect. And the oldest, most distant data we have comes from the cosmic microwave background, or CMB. This CMB is the faint afterglow of the Big Bang, a wall of light that surrounds us in every direction. It is quite literally the edge of what we can see. Beyond that wall, the universe was so hot and dense that light couldn't travel freely, so we have no direct evidence of what lies past it. Every theory we have about dark energy, the expansion of the universe, out where its ultimate fate, is built using observations made asterisk within asterisk this cosmic bubble. It's like we're ancient cartographers, trying to draw a map of the entire world, but we can only see as far as the coastline. Our entire cosmic map is bounded by a horizon we can never sail beyond. Now, this leads to a fascinating psychological twist. Because we are at the center of our observable universe, it's easy to fall into the old trap of thinking we are at the center of asterisk everything asterisk. But this is just an illusion of perspective. The horizon is centered on Earth only because we are the observers. An alien astronomer on a planet in the Andromeda galaxy would also see themselves at the center of asterisk, their asterisk own observable universe. A sphere 46 billion light-years in radius, overlapping with ours, but with a different center. This is an incredibly humbling realization. It reminds us that our view of the cosmos is profoundly local, not universal. The cosmic horizon forces us to confront our own limitations. It shows us that our window on reality is just one of countless overlapping windows, each with its own unique but equally valid perspective. We're not the center of the universe. We're just the center of our own view. The scale of that view is just staggering. Let's try to wrap our heads around the numbers. A sphere with a radius of 46 billion light-years. Within that sphere, astronomers estimate there are around 2 trillion galaxies. And in those galaxies, there are something like a septillion stars. That's a 1 followed by 24 zeros. It's a number so large that if every star were a grain of sand, you could fill every beach on Earth thousands of times over. And yet, all of human history, every empire that has risen and fallen, every scientific discovery, every love story, every personal struggle has unfolded on this single, tiny planet. A pale blue dot orbiting one very average star in a quiet suburban spiral arm of the Milky Way galaxy. Thriving from our perspective here on Earth, the cosmic horizon is a beautiful paradox. It is unimaginably vast, stretching our minds to their breaking point, but it is also finite. It simultaneously shows us how infinitesimally small we are in the grand scheme of things, and how incredibly lucky we are to even exist and be able to glimpse this tiny fraction of the whole. But our cosmic horizon isn't just a limit. It's also a laboratory. It's a time machine. When we look at the most distant objects, we are not seeing them as they are now, but as they were billions of years ago, because it took their light that long to reach us. The light from the cosmic microwave background at the very edge of our observable universe has been traveling for 13.8 billion years. By studying the tiny fluctuations in this ancient light, scientists have been able to measure the age of the cosmos, its composition. How much is normal matter, and dark energy, and even see the initial seeds from which all the galaxies, stars, and planets eventually formed. Our cosmic horizon gives us a fossil record of the early universe. Without it, we would know almost nothing about the Big Bang. We wouldn't have a creation story backed by evidence. Now, the universe's greatest limitation is also its greatest gift. It offers us a stunningly clear snapshot of the cosmos, as it was just 380,000 years after the beginning of time. This boundary also forces us to think about the nature of knowledge itself. It's a stark reminder that our perception of reality is, and perhaps always will be, bounded. Our ancestors once looked up and believed the stars were just tiny lights fixed to a celestial sphere, because that's all their senses and tools allowed them to perceive. We laugh at that now, but are we so different? We to live inside a bubble, a cosmic dome defined by the speed of light and the age of the universe? We can't see beyond it. This raises some of the biggest questions we can ask. How much of reality is forever hidden from us? Will science ever be able to describe everything? Or is it destined to only ever describe the part of the universe that is accessible to us? Is the cosmic horizon a temporary scientific boundary that future breakthroughs might overcome? Or is it a permanent philosophical one, an absolute limit to what humanity can ever know? These aren't just questions for cosmologists in their ivory towers. They belong to all of us who have ever looked up at the night sky and wondered about our place in it all. Ultimately, the cosmic horizon helps to define our cosmic identity. It frames who we are, reminds us that on one hand, we are profoundly insignificant, fleeting consciousness on a speck of dust adrift in an immeasurable ocean of galaxies. But on the other hand, we are extraordinary. We are the part of the universe that has woken up, capable of observing, measuring, and understanding that vast ocean. Carl Sagan famously described Earth as a pale blue dot in a photograph taken from the edge of our solar system. From the perspective of the cosmic horizon, our entire galaxy is a barely perceptible smudge. But from our human perspective, our ability to comprehend this scale is immeasurably large. The horizon defines the stage on which the human drama unfolds. And while it may confine our vision, it also connects us to the greatest story ever told, the story of the universe itself. Have you ever looked up at the night sky and wondered where it all ends? What is the edge of everything we can see? The story of how we found that edge isn't just about physics. It's a tale of human curiosity, genius, and the relentless desire to see just a little bit further. This is the journey to the horizon of our universe. For almost all of human history, our universe was only as big as what our eyes could see. Stars, planets, and the beautiful smear of the Milky Way, that was it. Ancient civilizations, from the Babylonians to the Greeks, masterfully tracked and mapped these celestial bodies, believing Earth was the center of it all. The cosmos was a familiar, predictable dome above us. Then, in 1609, everything changed. An Italian astronomer named Galileo Galilei pointed a simple homemade telescope at the sky. What he saw shattered the old world forever. He discovered moons circling Jupiter, proving that not everything orbited the Earth. He saw mountains and craters on our own moon, revealing it was a world, not a perfect heavenly orb. And he saw that the Milky Way was made of countless individual stars, invisible to the naked eye. The universe wasn't just bigger than we thought, it was unimaginably vast. Galileo had poked the first hole in the celestial sphere, and through it, we began to see the true scale of reality. Over the next 3 centuries, telescopes grew larger and more powerful. We discovered new planets, mapped distant nebulae, and began to understand that our sun was just one star among billions. But the next great leap in our understanding wouldn't come until the early 20th century, at an observatory perched on a mountain in California. There, an astronomer named Edwin Hubble used the colossal 100-inch Hooker telescope to study faint, fuzzy patches of light that were then called spiral nebulae. He proved these weren't clouds of gas within our own galaxy. They were entire galaxies themselves, islands of stars, millions of light years away. But his most revolutionary discovery came in 1929. By analyzing the light from these distant galaxies, Hubble found something astonishing. Nearly all of them were moving away from us. And the farther away a galaxy was, the faster it was receding. This wasn't just random motion. The entire fabric of space itself was stretching, carrying the galaxies along with it. The universe was expanding. This discovery was monumental. If the universe is expanding, it means that in the past it must have been smaller, denser, and hotter. It implied a moment of creation. And it also introduced a profound new concept, a horizon. If the universe has a finite age and light travels at a finite speed, there must be a distance beyond which light hasn't had enough time to reach us. For the first time, the edge of the observable universe became a real scientific idea. We now had a name for the boundary of... Have you ever stood at the edge of the ocean, staring out at the horizon, and wondered what lies beyond what you can see? Now imagine standing at the edge of the entire observable universe. It's a strange and humbling place to be. On one side, we have everything we've ever discovered. The dazzling tapestry of galaxies. It's the echoes of the Big Bang, all mapped out by our incredible telescopes and theories. On the other side, a profound cosmic silence. Regions of space forever cut off from us, hidden by the relentless expansion of the universe itself. The light from these places will never, ever reach us. And this forces us to ask one of the biggest questions of all: what lies beyond the horizon? One of the most fundamental debates in cosmology is whether our universe is finite or infinite. Think about it. If the universe is finite, then somewhere out there, beyond our horizon, there could be a true edge. Or perhaps space itself curves back on itself like the surface of a sphere. In that kind of universe, if you could travel in a straight line for long enough, you'd eventually end up right back where you started, just like sailing around the Earth. But what if the universe is infinite? If that's the case, our observable universe is just a tiny, insignificant bubble in a truly endless cosmic ocean. Beyond our horizon, there would simply be more of everything. More galaxies, more stars, more planets, stretching on forever and ever. All the evidence we have so far suggests the universe is flat, which points towards it being infinite. But because of the horizon, we can't know for sure. It's a tantalizing cosmic mystery we can see, but can't solve. What if the answer is even stranger than just more universe? Some of our most advanced theories, like cosmic inflation, paint a truly mind-bending picture. Inflation suggests that our universe began as a tiny bubble that expanded exponentially in the first fraction of a second. The theory also implies that our bubble might not be the only one. Imagine a cosmic foam, an endless sea of energy, where new universes are constantly bubbling into existence. This is the multiverse. Each of these bubble universes could be completely different from our own, with its own unique laws of physics, its own fundamental constants. Maybe even a different number of dimensions. Our entire cosmic story, from the Big Bang to right now, could be just one book in an infinite library of realities. But here's the ultimate catch. How could we ever prove it? By definition, these other universes are outside our own, beyond our horizon, forever out of reach. The multiverse might be the greatest paradox in science, a theory that could potentially explain everything, but one we may never be able to test. Now, here's a thought that's both fascinating and a little sad. The expansion of our universe isn't slowing down. It's accelerating. This means that galaxies we can see in the sky tonight are, one by one, being pushed away from us faster than the speed of light. Over billions of years, they will cross our cosmic horizon and vanish from our sight forever. Imagine a future civilization, billions of years from now, looking up from our own Milky Way galaxy. Their night sky would be almost completely dark and empty. They'd see the few galaxies in our local group, but beyond that, nothing. To them, it would seem as if the vast, galaxy-filled cosmos we know never even existed. This makes our time, right now, incredibly special. We live in a privileged cosmic moment, a unique window in time where the universe is still bursting with light and information for us to study. We are the lucky witnesses to a grand cosmic spectacle that is slowly but surely fading away. This cosmic horizon isn't just a physical barrier in space, it's a philosophical one. It forces us to confront the limits of what science can ever know. If a huge part of reality, maybe even an infinite part, is forever hidden from our view, can we ever claim to have a complete picture of the cosmos? Are we destined to live inside this bubble of perception, forever ignorant of the whole truth? It's a humbling thought. But for many scientists, this isn't a sign of defeat. It's a challenge. It's a call to be more creative, to push our theories, our mathematics, and our imagination to their absolute limits. The edge of what we can see is where the most exciting science happens. It's the ultimate frontier, not just for our telescopes, but for our minds. So, are we stuck? Will we never know what lies beyond? Maybe not directly. While we can't physically cross the horizon, future technology could give us new ways to peek behind the curtain. For instance, gravitational wave astronomy is still in its infancy. One day, it might allow us to detect the faintest echoes from the Big Bang itself, giving us clues about the universe in its very first moments, long before the cosmic microwave background we can see today. Powerful neutrino telescopes could reveal new particles and forces that are invisible to our light-based instruments. And who knows what humanity might be capable of in the far, far future. We might develop technologies we can't even dream of today, allowing us to probe the very fabric of space-time in new and profound ways. We may never see beyond the edge with our own eyes, but we might just be able to infer what's there by studying its subtle fingerprints on the universe we can see. The end, staring at the cosmic horizon, is like looking in a mirror. It doesn't just reflect the boundary of our universe, it reflects the boundary of our own knowledge. It's a constant reminder of how much we've learned, but also how much more there is to discover. And standing before it, we're left with a profound choice. Do we accept that we can only ever see a small piece of the cosmic puzzle? Or do we keep reaching for what lies beyond, driven by our insatiable curiosity, even if we know we can never truly touch it? The edge of the observable universe isn't an ending. It's not a wall. It's the beginning of the greatest mystery we have ever faced. It's an invitation to keep wondering, to keep exploring, and to never stop asking, what's next?